In this video, we're going to look at confidence interval for population proportion. So we're trying to estimate proportion from a population. So let's look at some notations. Lowercase p is the population proportion of individuals who are in a specific category. So this is the parameter, a parameter that we want to estimate. X is the number of individuals in the sample who are in the specific category, and n is the sample size. And p hat, we pronounce this p hat is the sample proportion, which means this is the point estimate for these problems. And the way we find a p hat is x divided by n. Okay, so we can always find the sample proportion from the sample we collected. So some assumptions we're making for confidence interval for proportion, population proportion, is we have a simple random sample. Population is at least 20 times as large as the sample. And the items in the population are divided into two categories. And sample must contain at least 10 individuals in each category. It's not that, for example, this 20 sample and the 10 individual is a must, but if we don't have that, the results are even less accurate. Okay, so to be more accurate, these are things that we're assuming. If the above conditions are met, we can construct confidence in the following way. So the point estimate, now we're not doing the mean anymore, we're doing the proportion. So sample proportion is the point estimate. So we begin from this number, which is x divided by n. From here, we add and subtract margin of error. In order to find margin of error, we need critical value. Remember, this is ZC. Also, need to know both notation. ZC corresponds to desired confidence level from the it's not t distribution. So it's not t distribution from Z table. So for population proportion, we only need to worry about Z table. Okay. But remember, for confidence interval, we have a specific table just for the confidence interval, right? For confidence interval. Let's write confidence level. So let me show in the picture. I'm referring to this one right here. We can use this table for proportion problems. We don't look at the whole Z table as we discussed in earlier video, one of the earlier video. So we can use this table to find a critical value with the corresponding confidence level. And the way we calculate standard error is sample proportion times 1 minus sample proportion divided by n, square rooted. And in order to find critical value, which we using confidence interval, and multiply these values. So this is the margin error formula. And in terms of confidence interval, we do plus minus of margin of error from the proportion. So let's look at an example so to see how we apply this. The main theme is same. We are adding and subtract margin of error from point estimate. Find the point estimate, standard error, and the margin of error if x is 46, n is 57. So whatever the context is here, 46 is the category we're interested in, and out of 97. So point estimate is p hat. Because we're trying to estimate population proportion, sample proportion is the point estimate, which is x divided by n, 46 over 40, 97. So this is the point estimate. From here, we add and subtract margin of error. Okay. So let's find standard error. Standard error is just square root of p hat times 1 minus p hat divided by n, and square root the entire thing. Well, p hat is 46 over 47 multiplied by 1 minus 46 over, 97. divide by 97, and square root the entire thing. Then we get 0.0050699. Okay. So let's find critical value. Critical value. Critical value, which is known as ZC or Z of alpha over 2, for 99%. Here we're looking for 99%. So we go to the table. 99% is 2.58. So just write 2.58. 2.58. So the margin of error is then just multiply these two numbers. So let me go to the formula just to remind you what it is that we're doing. In this case, we're doing this portion right here. So this portion is standard error, critical value. If I multiply those two values, I get margin of error. So just multiply these two to find a margin of error, essentially this times this. So margin of error is 2.58 times 0.0506998. And we get 1.13, excuse me, 0.06027. So this is the margin of error. So from here, we can add and subtract point estimate to find the confidence interval. Yeah, but this is the basic idea. We'll look at a full problem later, but let's look at another problem. Find a confidence level of 95% with x equals 125, n equals 317. So first, we always find point estimate first. Point estimate. We're trying to estimate population proportion. Therefore, sample proportion is the point estimate. X over n, 125 over 317. So this is the point estimate. Standard error, and if you prefer, you can find the margin of error just in one line. You don't always have to do separate like I did earlier. Margin of error is critical value. Let me actually show the formula again. I'm just copying down this formula. So you can just write it only once. Formula all at once. Square root p hat times 1 minus p hat divided by n. So let's find the critical value for 0.95. Well, 0.95, we use this. 1.96. For this is be 1.96. So then let's write those numbers down. Will be 1.96 multiplied by p hat is 125 over 137 multiplied by 1 minus 125 over 137 divided by 137. Make sure to copy down the correct numbers. Here's the sample size, which is given here, n. So then if I calculate this, I multiply this and this number, the calculator, I get 0.027448. Yeah, 6 decimal should be good enough. So that's the margin of error. Oops, sorry. I actually forgot to multiply. So you can make sure to test this on your own calculator. Let me do separately. This number itself is 0.027444838. And now we multiply these two numbers to get the margin of error. Therefore, margin of error, I get 0.053798. Yeah, 6 decimals should be good enough. So for the confidence interval, itself is p hat minus margin of error, p hat plus margin of error. So in this case, we have 125 over 137 minus margin of error. 125 over 137 plus margin of error. So what is that? We can find this number. Let me write it right here. You get 0.341. Let's just round to 3 decimal. P 0.0537. Oops, sorry, I wrote the wrong number. It will be 0.448. So this is the confidence interval. That means we're 95% confident that the population proportion is in between 0.341 and 0.448. So using the formula, we found a critical value 1.65 from the table right here. 1.96. Oh, I'm sorry. 1. We're doing 90%. 1.9, so it'll be 1.65. And p hat, we found it earlier. So just calculate this. Then you get, for this, you get 0.024. Write it better. 0.024556. So this is the margin of error. So from here, we do plus minus from the point estimate. So p hat minus margin of error, p hat plus margin of error. So 75 over 540 minus 0.024556. 75, 540 plus point estimate. Oh, excuse me, margin of error. So then as an answer, I get, let's round to 3 decimals, 0.114, 0.163. So this is the final answer. So what does this mean? It means we are 90% confident that the population proportion of all customers who experience interruption is between 0.014 and 0.16. So between 11 and 16% of customers experienced internet interruption last month, and we're 90% confident of that. So the company's quality control manager claims no more than 10% of its customers experienced an interruption during the previous month. Does this confidence interval contract this claim? It does contract, yes, it contracts because between 11%, let's say 11%, and 16% experience the interruption, experience an interruption. Right? So it does contradict because according to our confidence interval, which is 90% confidence interval, this was the estimate for population proportion. So let me go back to the formula. Again, it's very important that you identify what it is that we need to do. We're confidence interval for population proportion. How do you estimate population proportion? We use this formula for margin of error. And for proportion, we do not need to worry about student t distribution. For proportion, we always use this table for critical value right here, the bottom table. Finding necessary sample size. Okay. So let n be a desired margin of error. And let critical value be critical value z of c. Again, we use two symbols z of c. The sample size n needed so the confidence interval proportion will have margin of error. Specific margin of error is this formula. Again, this is with proportion. we're working with the proportion. Okay. And if p-value is available in the problem, we use this formula. If p is not value, so it should be just p-value. If no p-value is available, we use 0.5 for p. We're just estimating. Okay. So let's just look at a problem. I think it will make more sense if we look at a problem. But just like the mean problem with the minimal sample size needed, we round up. We always round up this answer to nearest whole number, regardless of normal rounding rules. That's very important. So let's look at a problem. A medical researcher wants to construct 99% confidence interval for a proportion of knee replacement surgery during result in complications. It is suggests that 8%, this is the then proportion. 8% of knee replacement surgery result in complications. Using this estimate, what sample size is needed so that confidence interval with a margin of error of 0.04. So remember, when you read the problem, you need to be able to identify what it is asking. This is not asking us to calculate confidence interval. It already gives us the margin of error value. It gives us the proportion in this case. So it's asking what sample size needed. And that's how you identify to recognize, okay, minimal sample size problem, we're using this because we're doing proportion. If we're dealing with the mean, we use this formula, which we saw in earlier video. So here, we're using this formula. So E is margin of error. I use M. Either one is fine. So let me just copy down this formula right here. Well, minimal sample size needed is P times 1 minus P multiplied by critical value over margin of error square. So P here, strictly we can think as a proportion, sample proportion. But what's important is this P is given in the problem. So we use 8%. 8% is 0.08, right? 8% is equal to 0.08. So we plug this value, 0.08 times 1 minus 0.08. And margin of error, this is given right here. Margin of error is given. So write the number down, 0.04. The critical value is for 90%. They want to do, 99%. So we find that 99% critical value from the Z table or the confidence interval table. 99 is 2.58. 2.58. 2.58. Okay, for 99%. And important thing is also we have to square this value. So don't forget that part. So that's how we calculate. So we multiply these numbers, then you get about 305.2457. We always round up. We always round up to nearest whole number. If you follow regular rounding, it would be 305. But we always round to nearest whole number. So 306 is the minimal sample size this researcher needs to ensure that we have a margin of error of 0.04. Okay. So this is minimal sample size problem. So make sure you know how to identify which formula. Estimate the sample size needed if no estimate P is available. So let's say they don't have P here. They don't have this 8% approximately. Then for P, we just use 0.5 as an estimate. So that's why it says here, if without an estimate of P, we just use 0.5. So we use the same formula, but we use 0.5, 1 minus 0.5. Same thing for ZC. 2.58 for 90%, 99% confidence interval. Margin error 0.04 square. And this gives us 1036.84. We round up 1037. So this is the minimal sample size. This is the minimum number of individual we need to collect to ensure that we have a margin of error of 0.04 with 99% confidence interval. 99% confidence interval. If the P is not available. Okay. So let me review here again. In this video, we looked at confidence. If the problem says find the confidence interval proportion, we use this formula. And if it's minimal sample size with the proportion, we use this formula. And for critical value for proportion, we look at this table right here. Level of confidence, the bottom one right here.